So how would your weight change if you decrease the radius of the Earth? So if you're here, yay, you're on Earth, and you decrease the radius of the Earth, you're essentially changing the distance, right? So we have a big distance and you have a little distance. And so if you decrease the distance in this formula, m1, m2 divided by d2, d squared, if you decrease the distance, then basically what you're going to do is you're going to increase the force. So the force increases. Let me give you an example. m1, m2 divided by, let's say d equals 2. So that'd be divided by 4. Or m1, m2 divided by, let's say d equals 1. That'd be 1 squared. That'd be 1. See, this one would be bigger. So you increase the weight because that's the force of gravity. So that's weight equals force of gravity. Duh. All right, number 11, draw yourself spinning your brother or your sister in a circle and then letting them go. So my sister's almost 40, so this would be really hard. I'm going to draw a little head there, little body. Yay! So if I let go right here, my sister would go, and she'd just keep going, except she'd fall down because of gravity. And how would your linear speed of your hands compare to your feet? So if you think about it, your arms are out. So I'm going to draw, this is my head, these are my hands, and my arms are forming that circle, right? My feet are down here, making a circle down here. So you got to remember 2 pi r, you know, the whole circumference thingy. So if you look, this is a bigger circle than this. So this is more distance than this is, but it takes the same amount of time. So your hands have a large distance and your feet have a small distance. Okay, but you're dividing them both by t. So a large distance divided by the same t, small distance divided by the same t, your hands are faster. Which, if you just watch someone spinning really fast, you can tell, because like their hands and their arms are all blurred, but their feet are moving slower. So are you spinning a ball? Oh, are you spinning a ball on a string over your head? I think that's supposed to be you are spinning a ball on a string over your head. Explain what's happening to the force on the ball at your hand and on the ball itself. So if this is my hand and this is the ball, okay, my hand is pulling the ball in towards my hand, okay? So the force, the centripetal force, is in towards my hand. That's the force on the ball, okay? Now, if you look at the force of on my hand, that's going to be pointing in the opposite direction, but this is a reaction force. So this is just your reaction force. The centripetal force points in and the reaction force on the ball points back out. So if you're spinning a ball that has twice the mass as the ball in question 13, what would happen to the force if they're spinning at the same speed? So there's a formula for that, and the formula is the force, the centripetal force is equal to mass times velocity squared divided by the radius, and that is, let me draw you 2 little pictures. So we have this, and we'll say that that mass of the ball is 1. And we have this, and we're going to say that this mass of the ball is 2. Okay, so if I double the mass in this formula, it's the same as multiplying the formula times 2. So the force is doubled. I will tell you that tomorrow you will have to use this formula on the test. I'll give you the mass. I'll give you the velocity, I'll give you the radius, and you have to plug it in and solve for force. It's pretty easy. What are Newton's laws of motion? No particular order. You have inertia, that's the first. F equals ma is the second. And you have every action equal and opposite reaction is the third. And you don't actually have to know the numbers, I just need you to understand the laws. So you need to understand the concept of inertia, you need to be able to do F equals ma, and you need to know every action has an equal and opposite reaction. Draw a picture of how you would make a block of wood move with only two forces. The easiest way to make a block of wood move with only two forces is to just drop the block of wood, because the force of gravity is going to pull it down, and then you're going to have some amount of air force, the buoyancy from the air, that's going to push it up, but it's still going to fall down because wood doesn't float in air. But you could think about it the same way we did with the question from the warm-up the other day, where if I push on this corner of the block and you push on this corner of the block will actually spin. And remember, we called that torque. And then what is inertia and what does it have to do with mass? It's every object, oh, not every object, it's, sorry, it's an object at rest. An object at rest stays at rest. And then an object in motion stays in motion until acted upon by an outside force. Now, if you think about it, if you have a Mack truck and a 2-year-old and they're both at rest, which one takes a larger force to go ahead and start moving? And the answer is the Mack truck does. And then I would say, why does the Mack truck take a larger force? And you would say because it's heavier, so it has more mass, and the answer is actually because it has more inertia. So for the purposes of high school physics, you can think of inertia in your head as the more mass it has, the more inertia it has. So more mass, inertia goes up. And then draw a picture of an object at equilibrium and label the forces with the numbers and the arrows. So here is our free body diagram. We're going to have the force of gravity. We're going to have the normal force. And those have to be equal and opposite. So gravity is 9.8 meters per second squared. So that means the normal force would be 9.8. But we have to put those in newtons. So let's say that we'll just make it easy. We'll just say the object basically has a mass of 1. So we'll say 1 newton up, down, 1 newton up. So if I have a force going this way and this is my action force, and I say that this is 3 newtons, then I have to have, if it is in equilibrium, they have to be equal. So the force of friction would have to be 3 newtons in that direction. Does that mean that this is at rest? No, it means it is at equilibrium, which means there's no acceleration. And that's it. Good luck on the test tomorrow.